Welcome everybody to the new week, whichever week this is. Let's go ahead and get Unreal Engine going. I want to talk today about doing damage, because that's kind of an important thing, right? And then our weapons can actually, kill the bad guys and stuff like that. And maybe we'll do something like the procedural. Let's see, procedural spline walls. Yeah, let's do that. Let's add that to my fall 2021 project there. 1.5 gigs. Okay. Use sockets, add the mesh, then use parent bone. Yeah. Yep. Okay. So let's talk more about weapons, because a lot of video games have weapons in them, and we're going to talk about damage and stuff like that as well. So how about that frame rate? That's looking pretty good. All right. And we got still our ocean over here. All right. We got our switches. Okay. All right. So what should we start with? I guess we can start with like some sort of AI, right? Let's make some sort of AI that can fight us. Maybe. Does that seem reasonable? You guys want to learn how to put AI into the game? Because we're getting like this close to like actually having like a workable game. There's a couple more important pieces. Sound. We've talked a little bit about sound. Go away, human. We need sound, music. We need a main menu when you launch the game, like welcome to the game, that kind of stuff. There's a couple important pieces missing, but like I think having a bad guy is kind of one of them, right? We've been doing a lot of art, and art's important. Having things like the water move around and the lake and the ocean system. All that's important. But we really kind of need to have an opponent in this game, right? Right now, this is kind of like a tech demo. It doesn't really, like when we play it, I can come over here and shatter the things with, which is all, very cool stuff, honestly. It's actually kind of cool. But it's not a game, like, because there's no point. Like, there's no, right? You know what I mean? Like, there's no objective. We're just kind of, like, tooling around and having fun, just, breaking boxes and stuff like that. So let's do this. We've got old Yeller here. I think I'm just going to leave Yeller the way it is, and we'll just make a new one. All right, so we'll come over here and go away, human. Okay, we'll just leave Yeller. We'll just make a new bad guy. So we're going to do this by right-clicking, choosing new blueprint class, and we're going to choose a character. So maybe I should go over this really fast. There's a couple different kinds of... There's actually a lot more than this. If you click on all classes down here, you can see there's quite a lot of things you can put into the world. These are kind of the ones they picked out as like the most important. And if you ever forget what they are, there's a little help system there. You can click on it and it spawns a 404 page. Wonderful. Well done, Unreal Engine. That is so helpful. You can see how often somebody clicks on these things. Let's click on that one. 404 page not found. Super neat. Clap. Well done. Well done, Epic. You only make $9 trillion a year. You can't afford to keep your hyperlinks up to date. Okay, so I'll explain them to you. So an actor is anything that can go into the world. And so it's in other game engines, they're called entities, which is maybe a better term, because an actor sounds like somebody that's like in a stage performance, that's like going, oh, or to be or not to be, that is the question, whether 'tis nobler in the mind to suffer the slings and arrows of outrageous fortune, or to take arms against the sea of troubles, and by opposing in them, to die, to sleep. No more, by sleep to say, we end the heartache and the thousand natural shocks that flesh is heir to. 'Tis a consummation devoutly to be wished. To die, to sleep. To sleep perchance to dream. Aye, there's the rub, for in that sleep of death, what dreams may come when we have shuffled off. Anyway. So, that's not what an actor means. An actor is anything that can appear in the world. And they don't even have to have like a physical body. You can put lights in the world. You know, they don't actually have like a thing that you can run into. It's kind of anything that you can put into the world as an actor. Okay. So a pawn is something that takes input from a controller, and a controller is one of these things. And let me see if I can find the controller in here. Controller, third person blueprints, somewhere. Third person. So controller is, you can think of it as not like a physical controller, but like a code construct that actually moves things around. And where'd I go? I cancel that. And so the most common type of pawn we make is something called a character. And so a character is a pawn that can walk around. And so that's what we're going to be making here. We're going to be making a we're going to be making an AI that can walk around. It'll walk towards us and, I don't know, try eating us or something. What kind of bad guy do you want? I'm open-ended on this topic. All of life's a stage, and we are but players. Yeah. A lot of good speeches in Hamlet. Let's be real. It's a pretty good play. What kind of bad guy do you guys want to have? I'm not gonna make it like an airplane or something like that. Sock goblin. We can do a goblin. I don't know about a sock goblin. We can do a goblin. All right. So a player controller is you, basically, like your character, the knight that I have walking around. That is a player controller. But an AI is going to be a character, and if you make it an actor, you can kind of hack it together to work like a character. I've done it before. It is just annoying. Like when you pick these parent classes, it gives you a lot of stuff kind of for free, and it just makes life easy. Game modes control things like rules and things like that for the world. If you go to the world settings, let's see, game mode, selected game mode here. You can do things like set the default pawn class, the heads up display, HUD, heads up display, things like that. So you can kind of override those things with the game mode. And then these are a component is something that can be attached to an actor, like when we've got our person. That's the skeletal mesh, isn't it? No, that's the animation. We got our character here. All these things that we can attach to it, like a camera. The arrow component, which shows you which way is forward. These are all components, right? Arrow component. A little bit of terminology there. And so we are going to be making a character. And we will call this one Sock Goblin. Sock Goblin, yeah, sure. I don't think it's going to be a Sock Goblin, but yeah, whatever. Let's work on this. Okay, so first of all, we need to have a mesh. So a mesh is a collection of triangles. We've talked a little bit about the humble triangle and how you can build anything out of a triangle. Right. So if you ever see something, oh really, nothing. Like this is a mesh, right? So this is a collection of quads. It's not triangles, but whatever. So this is a mesh. And there's kind of two different kinds of mesh. There's static meshes that don't move. So for example, I could put a square there or something like that and have a box come after us, which I've done before. It's when because animation's kind of annoying, and we'll probably have to get into animation at some point. So maybe I'll just do a box for now. What do you think? Or see if we can find a goblin maybe. What do you guys want to see an actual goblin, or do you want to use a box? It's a fork in the road. Do you want to see how to import skeletal meshes? So there's two kinds of meshes. There's static meshes, which don't move like a box. It's just a box. And then there's skeletal meshes, which have bones and things like that that can individually rotate around, right? So which one do you want to see? box to start. Cool. All right. So add a component, and we'll just add a cube, and we'll just call this the Goblin. Let's call it the body. Okay. And let's just scale it down a little bit like this. Then we don't have to animate it for now. Okay. So here's our Goblin. All right. Easy peasy. What material? Let's make it Goblin material. That's kind of terrifying, actually. It's like a walking bush coming after you. Yeah. It's kind of horrifying. Yeah, let's do that. Okay. So just have some sort of like alien creature coming at us like this. Okay, so we've got here a goblin. It's a glass goblin or something. And then you'll see that there's a character movement attached to this thing. This is what makes it a movable kind of. It's got all the different rules for movement on it. Max acceleration, how much mass it has, by default it walks. If it falls into water, I can show you guys how to mark areas as water. That's something we probably should do over on the lake area. This is kind of important, the max step height. So when you walk into a wall, if it's a really short wall, you step up onto it. If it's too high, you bounce into it. Okay. And this is the angle that you can walk up. So for how steep a hillside can this thing traverse? And if it's a Skyrim horse, it's 90 degrees, right? They're very close to it. So that number is set too high for horses in Skyrim, because everybody is like, that shouldn't be possible. So horses in Skyrim have like some crazy walk angle on it. Friction, max walk speed, walking speed while crouched, all this kind of stuff. How you jump. Should be swimming under here. Yeah, if we swim, we fly. How fast it can rotate. Does it push things out of the way? Things like that. Okay, so we got this thing here. Let's go ahead and snap it here. And let's save it, compile it. And let's just drop out the sock goblin here. And that's all right. Okay. But if we play the game, you'll see that it's solid. It doesn't kind of do anything. It's not really fighting us at all, you know. It's kind of boring. All right. So, how should the AI behave? What do you think? You guys tell me. You be the game designers. How should this goblin act? Just in English. Attack? When does it attack? Is it a ranged attack? Is it a melee attack? Does it have 360-degree vision because it's a giant glass thing? Or does it only see forward? Hostile on sight, melee attack with cone vision. Okay. In that case, we should probably figure out a way of indicating which way it's for. You know, maybe we should just do the skeletal mesh. I don't know. Okay, let's see here. Let's add a cube to it, and it's gonna get a little bit stupid, but here we go. So that way it's forward. We're just going to leave that on there as just a little, just, you know what I mean? It's like, so otherwise we have no way of knowing which way is forward on this thing. Okay, so let's spin that around there. So we'll start off looking that way. Okay, so what happens if it can't see us? What should it do? Give me some English. What should it do if it can't see us? Wander around? Okay, so how do we wander around? First thing we need to do is we need to make a nav mesh. And let's see if we have a nav mesh on here. We do not. Okay. So let's make a nav mesh. And a nav mesh pre-computes which areas are walkable. And as long as the nav mesh has the same settings for like step sizes and things like that as your monsters and your players, then I guess the players don't matter as much, but for the monsters, then it can say, hey, you can walk down these stairs, you can do this, you can do that, and you can sort of manually do things like say, this is a spot you can jump from and stuff like that. So how do we add a nav mesh? We come over here, type nav, and we have nav mesh bounds volume. And that's not very big. So this would be the area the AI could walk in. Okay. So I think we will just, let's just limit the AI to the little gold zone here. Just for simplicity's sake, so it doesn't kind of wander off too much, you know what I mean? So I'm going to take this nav mesh bounds volume, and I am going to just scale it up and scale it up just so it kind of encompasses the gold zone here, and center it a little bit like that. Scale it up some more. Slide it over. Something like that, right? It doesn't have to be exact. If it can't nav over the last centimeter of the thing, it's not going to make a difference. And so there we go. And so notice how I make sure the height is encompassing the platform over here and the platform over there, so I can get up on the stage, and, or steps, or whatever you want to call that. And then if you hit the P key will show you which areas are navable. Okay. Is there not an easier way to scale things to other objects? Yeah, the easier way is just you type in the thing. Right? So if we have here the floor, and you know how big the floor is, then you can just type it in here. I don't know. I just sort of eyeball it. Okay, so do you guys see the green areas here? So the green areas are the places where the AI can walk to. And so there's a little dead zone around these snowmen, because the snowmen have like a bounding box around them that's probably keeping it out. You can see that the stairway has a pathway going up it, so it'll path up and down the stairs, and it can go over here. But I haven't set up like a navlink proxy to have it jump off, so it won't jump off, but it might navigate over there. So in fact, maybe we can just start the guy here. That could be fun. All right, so type P again to turn it off, and I will rotate 90 degrees that way, and I will and tap end, and tap end. There we go. So our goblin is going to start up here on the top of this thing, and voila, nothing happens. Why? Because I haven't told it to walk yet. Okay. So the first thing you have to do is set up the nav mesh. That's what allows AI to walk around. You can do it without it. Like I said, a lot of these things you can sort of cheat. You can just directly move the thing towards the player if you want, but then it's gonna like fly through walls and things like that. So right now we don't have an AI, right? So let's just start off by having the thing just nav towards us. Like, don't worry about vision, stuff like that. Let's just start off with it just nabbing towards us. So maybe once every like second, we'll have it nav towards us. Okay. So in order to do something once every second, you can set up a timer, which is one way you can do it. I'll just show you the quick and dirty way of doing it. So you create a last think variable that's going to hold the last time that we woke up and did something. Okay. And it'll just default to 0. That's fine. And so what we're going to do is every tick, we're going to see, hey, is it time for us to think again? If it's not, just go back to sleep. So somewhat expensive, not super expensive, unless you have a lot of these things. The more proper way of doing this is with the timer, but this is pretty easy to do. So what we're going to do is we're just going to say branch, and And how often can we think? So last think is the last time we thought, and then we need a think delay. And so that will be like 1 second. So once per second, it's going to wake up and do it. So how do we make that happen? Okay. What we're going to do is every time we think, we are going to set last think to the current time. So every time we do think, and we haven't quite figured out how to do this yet, every time we think, we're going to set the last time we thought to the current time. So we're just going to pull that out and say get time. And there's a few different ways of getting the time. You can have time increase if the game's paused. You can get time dilation, which will, like sometimes you can do bullet time and things like that, but get time seconds is really just the easy way of doing this. So this is going to just get the current time. And so every time we think, we're going to save that into this variable. Okay, so the last time we thought was at 1:58 and 20 seconds. Okay, and then every tick, we want to check to see, has it been a second since the last time we thought? So we're going to take the last time we thought, and we're going to get how often we think. We're going to add them together, like so. And then we're going to see if the current time is greater than the last time we thought plus a second. So when it's like 4 seconds in, let's say 4 seconds in was the last time we thought, and the current time is 4.1. It's not time to think again. Current time is 4.2, not time to think again. Current time is 4.3, not time to think again. Right? So we're going to compare this. So is the current time greater than or equal to, doesn't really matter which, is the current time greater than or equal to the last time I thought plus 1? If it is, it's time to think again. So this construction here is very common, and you'll see it in a lot of code. Like you'll just record the last time you did something, and you just check to see, hey, is it time to do it again? For example, let's say you have a button where the person can like honk the horn. You'll record the last time you honked the horn, and if they hit the honk horn again button, then you have some sort of minimum delay in there, because otherwise it would go right, because it takes a while for a sound to play, right? So you say, all right, minimum of 1 second between honking, right? So even if they sit there and spam the button, it'll go honk, 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 so you can use this pattern in a lot of things to limit the rate that the player can do things, okay? So you just write down the last time something happened. You write down how often you want to allow things to happen. Think delay is set to 1. So we get the current time. We see if the current time is greater than the last time we did something plus 1. And if we did, congratulations, we can now do it again. So now that we got this set up, and this I will screenshot for you because this is a code pattern to limit the rate you do stuff. When you say baked, the navigation is set after the game starts, so if movable objects move in and out of the nav box, the players won't be able to navigate to it. Yeah, so the nav mesh can update, and we can probably talk more about that. But yeah, it does try to pre-compute the areas that AI can walk to, so you don't have to waste all that CPU time. Okay, so now how do we walk someplace? So there's two functions to do navigation easily. One is to move to a player, or move to any actor in the world, but we're going to be moving to the player, or you can move to a location. So let's just have it move towards the player. Okay. So the controller, this is the thing that is going to be moving us, right? Pull that in there. No. So the AI controller is the thing that actually moves us around. And the goal is the person we're going to move towards. And so this will be player. So get player pawn. That should work. So if you have multiple people, you can have different players, but basically it's going to move towards player 0. And let's see if that works. And if it doesn't, then I'm going to go into a corner and cry, because when navving doesn't work, it doesn't work. I've had some very frustrating experiences where, like, I moved the nav mesh bounds around, and then everything stopped working. And so I undid it, and then it still didn't work. And I was just like, so let's see how this goes. Yeah, there we go. Excellent. So we have our goblin. Every second it wakes up and navs towards us. Okay. But look, when we get away from it, see how it doesn't move anymore? That's because the nav mesh bounds don't exist. It can't nav to us because we're outside the bounds. Within the bounds, it'll work. And it stops, right? I think it fell outside of the nav mesh boundary. That's funny. So now that it's outside of the bounds of the nav mesh, it can't walk anymore. It's stuck permanently. It's too funny. Dumb AI. Okay. Yeah, it is pretty fast. I wonder if it'll go through these things. Let's try that. Control W. Let's see if we can get it to come through like the Kool-Aid Man or something. Make it real narrow. It's coming for us. It's coming for us. Yeah, this is why scaling, by the way, is a terrible idea. When you scale something, everything looks garbage. Just took off Frosty's head or something. Okay, that's pretty cool, right? Come on, that's pretty cool. Got it. That's pretty cool. Let's make this a little thinner. It's like the the football games when they like come busting through the. It's like I'm just admiring myself in the mirror. Ow, Lord! Okay. So that is a basic AI for movement. Oh yeah! Right. So yeah, so it'll nav around, and the nav mesh bounds control the area it can navigate. So you can limit the areas that it'll walk around to. How did it get off this side? It's probably because it's probably a little bit off the edge here. Either way, I don't care. Okay, if I made it a little bit bigger, then it could probably navigate that step. I think it had some velocity and just like kind of ran out of the bounds. Okay, what should we do next? So we got this thing navigating towards us. Who is it that said have it wander around randomly? Okay, so what we need to do is have it figure out if it can see us. Okay? Have it figure out if it can see us. So what of our techniques do we know we can use to do line of sight? I've already told you all the basic ways you can have the game interact. What is the tool to see if it can see us? Collision mesh is if it runs into us, and we probably want to have some sort of interaction there, because right now it just kind of runs up to us, goes hello, it doesn't really do anything. There's no damage yet. So we probably should have some sort of collision, but yeah, I think trace line is the right option. So maybe every time it wakes up, it does a trace line. If there's a line of sight to us, navigate. How does that sound? Or if we're in front of it, right? Like a vision cone, somebody said. So let's just do line of sight first, and if that works, then we'll add in like a limited 45-degree line of sight or something like that, which will require mathematics. Okay. Trigonometry. Hazelton's leaving. Okay, so here we got our sock goblin. That isn't really a sock goblin, is it? I don't know what that is. A little bit terrifying. Well, let's make this a different color or something. Let's make this a chance. Oh, that should be scary. Yeah, I don't know what that is. Okay, so come back over to the event graph here. So every second it wakes up, and rather than just moving towards us, and this is the thing that kind of gets you sometimes, because like it's like, well, what is a controller? The AI controller is the thing that is doing the actual moving. So every frame, the AI controller is like, I've got a target. The target is there. Move me along the nav mesh. All that complicated stuff that's happening. It's happening inside of that thing there, the AI controller. And so in order to make this work, what happens is you give the AI controller a command. You're saying, AI controller, your mission is to move towards this player. And are there not simple moves? Yes, there are. But the basics of moving an AI is either move it at an object or move it at a location. So the dreaded mathematics color test texture, yeah. Okay, so rather than just directly moving towards it, we need to only move towards it if we can see the player. Okay, so let's just kind of get all this kind of out of the way a little bit. I don't know. Let's kind of stack all this up and just kind of move it out of the way. Okay. Wow, that's kind of far. A little too far. Okay, so now let's do a trace line. Okay. So we want to do a line trace starting where to where? Where's the beginning going to be, and where's the ending going to be? Top part of our box goblin. Okay. Maybe we should have this be its head, you know? Maybe. That seem like later on we're going to come in and put an actual skeletal mesh in it and stuff like that. But this is actually like, don't think that we're being like amateurish here. Like when you do a lot of stuff in professional game development, you block it out. You just have like you're doing a level design, you're making a Grand Canyon map, you just put down a cube and a couple cubes and you just kind of rough it out, you know, and see if the proportions are right and the gameplay works. Like roughing things out is fine. Like, you know, don't think too badly of us for doing this. The color test pen. Maybe we'll do, should be Goblin's head. Chrome. There we go. All right. So maybe the body can be chrome too. There we go. That's okay. So we want the trace line coming out of the head, out of the eyes specifically, and weeping angels. Yeah, we're fine when it comes this time. Yeah. So you just rough it out. And, you know, you get your proportions right. Like right now, I think it's a little tall for a goblin, you know, so we might kind of, you know, squish it down a little bit, but, you know, it's fine so far. So we want to have, we want to have a point on here where the eyes are. And so I'm just going to add a little component here. Let's see. Okay. And so this thing here is just going to be the eye point. I don't know. It's just really useful to just be able to mark spots on your model so that you can just use those instead of like guessing. Like have the trace line come out of my center plus 50 centimeters plus 20. Nah, just toss a little attachment on there. It's parented to the body, so wherever the body moves, the eye point will move with it. And then if later on we come in and replace this with a good skeletal mesh, we just move the eye point to wherever the eyes are on the skeletal mesh, or we add bones or something like that, or a socket or something like that. So yeah, this will work. So we've got our eye point here. So the starting point should be our eye point. Well, we got to get the location of it. See, I think that a nice thing they should add is like if you drag, a object over something that takes a location, it just does get location. I don't know. Seems like that would be a nice little quality of life thing. All right, so the starting point is going to be our eye right here, and then where is the ending point going to be? What is that component I added? I just added a dummy thing. It's called. I just added a scene. Sometimes you can add like a point. Yeah, but it doesn't appear here. In the world, you can add a point, and it's literally like a little target bullet looking thing, or like an archery target. And so you can just drop points in your world so that if you need to teleport to a point, you can give the point a name, like teleport location 5, and then when you teleport, it takes you to teleport location 5. But inside of this, you can only add components to it. So a scene component is just a dummy. It's just a dummy thing that doesn't have a model or anything. It doesn't draw, but it allows you to name points within the system without doing anything crazy. Okay. About 2 meters ahead in vision. Oh, interesting. So have it just do a line straight ahead. Okay. And if the player is straight ahead of it, then nav towards it. I was just gonna see if it could see the player, but yeah, that would work too. Or do you want it to just? I was thinking just if there's like open line of sight between the goblin and the player, like if you're not behind a wall, then it starts chasing you. Okay. Well, we did your idea last time with a gun, where we took the forward vector and did that. So this time, let's just get the location of the player. That's the easiest way of doing it. So get player 1. So we're going to get player 0, the first player. It's the easiest way of doing it. There's other ways as well, but it's pretty easy. So this gives us an actor. Anything blue like this is an actor. Actors are anything that can appear in the world. So we're going to drag that out and say get world get actor location. And that will be the end. So it's going to trace from the eye of the goblin towards the player's location. Whether or not that's a good idea, well, let's find out. So we'll turn the draw debugging on for 5 seconds. That's fine. So every second it's going to draw a trace line between us, and then we'll just look at this and see if it works. Okay. So there we go. So you'd see the goblin is in fact doing a line trace properly. If we're occluded, you see how there's a little square there on the thing. That's the hit location. Okay. Okay. But if it can see us, then the hit location is, us basically. Okay. So it seems all right. Like it's using our center point to see if it can see us. So like here, it would say it can't see us, and I think that. I mean, I don't know. Like, what do you think? Like, we could maybe fix that. You know what I mean? Like here, it can see us, but like if we're like partly occluded. Right now, it's trying to stare at our belly button. You know what I'm saying? So if you're like behind a chair, like it's like, I can't see you. It depends whether or not you want to mess with that. What do you think? Do you want to fix that, or just like leave it like it? I'm fine either way. Fix it? Okay. A couple different ways we can fix it. We could just come in here and add something to the Z direction, right? So we can come in here and just guess, so we can split this. Can we? Break all pin links. We're going to split. Okay. And so we can just add something to the Z value. So let's add, I don't know, 30 centimeters maybe? I don't know. Float plus float. So we'll add 30 centimeters to the Z direction. And then we will, we can just split this actually. Look up X to X, Y to Y, or we could do what's called make vector like that. Either way will work. X to X, Y to Y, Z to Z, and then for this one, append links, and then recombine. Yeah, you can do it that way too. Either way. So anytime you have something that has multiple sub-values in it, you can split them. And it just kind of depends what you want. Sometimes it's easier to have a single line like this kind of running around. Sometimes it's easier to... rather than doing this, I could have added this vector to a vector holding 0, 0, 30. There's always different ways of doing stuff. For me, I don't know. What would I prefer? Hard to say. It's kind of, I don't know, it's kind of obvious. I don't know. Either way. This isn't the right way of doing it anyway, so I'm not going to waste too much time on it. So now, look what it's doing. See how it's going after our upper chest now? So that seems more reasonable. It's still saying it can't see us, and we can see it, so maybe add a little bit more to it. Like 40 centimeters. So it's like eyeball to eyeball, kind of, you know. Ah, shattered. Okay. That's pretty good, I would say. It's like our jaw, kind of. Okay, so what we want to do is say if it can see us, then walk towards us. If they can't see us, then idly walk around. Was that what Tori said? Like if it doesn't see us, just kind of idle patrol or something like that. All right, something like that. By the way, there's a lot of AI exploits you can do in a lot of video games for this reason, because they only do a single line trace, and so all you have to do is block that one pixel, you know, that's connecting the AI to you, and you can like stand behind a stick like this in a lot of games, and the AI is like, no line of sight, can't shoot him. So wander around or patrol. Okay, so if we saw the person, then we'll do this. We're going to move towards the player. We can turn this into a macro, by the way. So this macro will be called move to the player. Do you see what I just did there? It's kind of cool, right? So you can, yeah, you can do that if you want, and just reuse. Let's see, can I hook that up? No, it doesn't hook up. Yeah, never mind then. Needs to be a function instead of macro then. Let's play it. Let's see, class function. There we go. Yeah, macro isn't as useful as functions. There. So we're going to call this one move to player, like that. Okay. And so you can simplify your blueprints, because I'm sure you've noticed how complicated your blueprints can get. So if there's things that you do over and over again, then you can just select. What I did was I just selected a bunch of them right-clicked and chose collapse to function. And then it copies them, pastes them into a function, and yeah. So there you go. The target on this one, oh, interesting. Why does it have a input parameter? Self. Interesting. Okay. Yeah, that should work, I think. In fact, let's run this. Let's make sure that works. There we go. There. Okay. All right. So go back into sock Goblin, and so you can use this to simplify. You use this to simplify your blueprints. Okay. Having a million lines going all over the place is obnoxious. Yeah, especially if you're reusing the same things over and over again, like this thing here, this pattern. It's very easy to drop into a function or something like that, or like I said, you can use a timer. Okay, so we don't want to move to the player all the time, though. We want to only move if we hit something. So I'm going to split this here, and return value true or false. Did we hit something? So that will go into a branch, a branchy branch, and what we're going to say is if we hit something. Yikes! Don't do that. Even that up. If we hit something, then move towards the player, because that means that our line of sight is unobstructed. And I'm sort of habitual with lining things up exactly. And then if we don't see something, then we want to just randomly patrol around. Okay, so we will do like a move to, let's see here, simple move to location. And the controller is going to be AI controller, and this is going to be self. Again, it's the same setup we had before. And so what location should we move to? Oh, the comments? Yeah, the comments are really nice. You select the thing and hit C. And what's actually really nice about the comments are move to player or randomly patrol, is that when you have a comment like that, you can actually drag that around and all of them come with it. So that's one of the really neat things about comments. Yeah. Okay. So what location should we move to? This is a XYZ, right? This is a world location. As it turns out, there's a function called getRandomPoint in navigable radius. So it can actually do that for you. So you can actually just say, hey, give me a random point somewhere within, somewhere near me. So my location is here. And within a 10-meter radius. And yeah, so it's just going to pick a random point within 10 meters. Or if that's too big, maybe it's too big. Let's do 5 meters. And it's going to find a point within 5 meters that it can navigate to, and it will, in 1 second. How far can it move in a second? Yeah, let's try it out. Let's see how this goes. Pick a random location in the Nav Mesh. Yeah, exactly. So let's do this and see how this goes. So it's navigating towards us. Now it can't see us. Ah! Then it, see how it like randomly walked away? And as long as I hide from it, it's just randomly moving around, right? Oh wait, is it backwards? You can see me, can't you? You can see me. Why are you randomly moving? But if I hide, Nav's towards me? It's this. Is my thing backwards? Oh, it's because if there's no hit, right? Yeah. Okay, so if we did not hit blocking terrain, yeah, so it was actually behaving exactly backwards, which is actually kind of funny. That's actually really amusing AI behavior. It's like if you're just like near it, it just is going to randomly kind of like move around, and stuff like that. So it's just kind of doop 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 doop, just sort of chaotically, just running around, stuff like that. Oh no, ah, But then the second you like leave the line of sight, then it's going to start coming for you. It's kind of like how a child behaves, right? Oh, I can see my mom, and it just sort of like runs around randomly. Wait, where did my mom go? Shoot, did I lose my mom? And then it's going to come, Mom! Oh, there she is. Okay. It's actually surprisingly amusing AI. It's like child AI right here. Just smashed it. So as long as it can see you, it just sort of like cruises around randomly, and then you hide. You hide from it. It's like, wait, where did my parents go? Oh, there they are. Okay, that's off. I kind of like it. Yeah, I'm actually kind of amused. But let's put it back the way we said we were going to have it. I might actually leave it at that because that's actually really funny. That's actually good. That's Bethesda style coding right there. It's not a bug, it's a feature, right? So now let's have it behave properly. So if it can see you, then it's going to nav right towards you. There you go. And it'll just sit there and do nothing. But if I leave the line of sight on it, then it will start just randomly patrolling around. It's just sort of randomly walking around. No, smash. And then if it ever sees me, then it starts chasing. And it can't chase me off the world. Okay. Are you using perception? No, we're using a line trace. Just a line trace. And we're not doing a cone. That's the next. The next step is the line of sight. So perception systems are pretty cool, but they're also not the easiest in the world to use. So we're just going to do this by hand. I do like that other way, though. It's kind of cool. I might put it back at some point. Okay. Yeah. Okay. So what we want is to do a cone, right? Like we want to only see the player if they're within, like, let's say 45 degrees of the direction we're looking. So yeah, I liked how that turned out. Let's go ahead and save everything. Let's hop into OneNote and let's talk about math. So IS50A, we don't even have one. Cool. All right. IS50A fall 2021. This will be like trig and stuff. All right. So let's say that the AI is looking this way and the player is over here. Can the AI see the player, assuming there's no walls or anything like that? What do you think? Or can the AI only see straight ahead? Yes, but barely. Well, what is the max angle? Right? Like, what if the player is back here? That's still an angle, right? It's just like a really big angle. So do you want to have, what is the cone of vision, right, that an AI has? I've said 45 degrees, but it kind of depends just what you want, 30, 80, I don't know. You tell me. I can program it however you want. Enemy line of sight better than some games where an enemy can see a pixel. Yeah. What's really bad is games where like there's foliage and like the foliage does not block line of sight, so you can't see the AI, but the AI just neglects the foliage, and it's like, oh yeah, you're right there, and they snipe you through 50 feet of bushes. It's so annoying. Okay. Hold a bucket in front of you. Yeah, that's... Or you put the bucket over the enemy's head. That's... 30? Okay. Well, so let's talk about this. So if you have a... this is called a vector, right? Every vector has a starting point and an ending point. x1, y1. And the ending point is x2, y2. And the ending point over here is x3, y3. So, if you want to get the angle between these two vectors, this vector here is defined as x2 minus x1 and y2 minus y1. This vector here is defined as x3 minus x1, y3 minus y1. Or we can just ignore that entirely and just go with the actual length of the vector. So this might be 1 in the x direction, 0 in the y direction, which is the same thing as that. It's 1 to the right and none up. So, and then this one might be, I don't know, 0.7 to the right and negative 0.5 down. 0.7 to the right and negative 0.5 down. Then we don't need to worry about these subtraction things. They're confusing and disgusting and too complicated for our simple brains to deal with. So we've got two vectors. We've got one that is 1, 0 and one that is 0.7 and negative 0.5. So how do we tell the angle between them? We're trying to figure out the angle. Now if the angle is within a certain threshold, then we say it's in front of us. So there is a very important thing in video gaming and math, I guess, but who cares about math? We're doing video games, called the dot product. So the dot product is defined like, well, it's defined as like the cosine, but let's give you an English explanation first. So if you have vector A and vector B, and you say A dot product B, this will be equal to 1. Okay. So the dot product of two vectors that are normalized, they have to be unit length 1. The dot product of two vectors looking in the same direction is 1. If A is looking this way and B is looking this way, if they're looking in opposite directions, then it's negative 1. And if A is looking this way and B is looking either to the right or to the left, A dot product B is 0. Okay? So that will give you an idea of how dot product works. So if they're pointed the same direction, it's 1. If they're pointed in opposite directions, it's negative 1. If they're pointed at right angles, it's 0. And these numbers move smoothly between them. So if A is here and B is here, the dot product is probably going to be like 0.7 or something like that. Okay? Something like that. Just eyeballing it. And so what you do when you want to do a perception system, you take the dot product of the two, of the direction I'm looking and the direction towards the player. And the direction towards the player, let's undo that cross through. The direction towards the player, too much. I can actually undo squiggles. This is amazing. The direction towards the player is too much. Their location minus my location. So this one here is your forward vector. That's your forward vector here. That's your forward vector. And then the direction towards the player is the player's location minus my location. Okay, so there's a couple different bits of math going on here. Let me do it in Unreal Engine, and I can refer back to this for you. Let's snap that over there. Okay. So, okay, so if the player, we want to first see if the player is within a 45-degree arc or something like that. So we have to do the following. What do we have? We have a arrow component. Where's that arrow component? Where is that? Let's see. Where is it? Okay, so anyway, this will work too. So the X is forward in Unreal Engine. It's not forward in other engines, by the way, but it is in Unreal Engine. So we can just take the forward vector of I point here. So we are going to grab I point and pull out from that and say get forward vector. Okay, so this is the direction we're looking. That is this right here, the direction we're looking. We're going to dot product that with the direction towards the player. So this is the direction we're looking. And we are going to dot product this. So we'll pull that down there and do dot product. Let's move all this up out of the way, maybe. And so you can see it's a fundamental mathematical thing. Dot product is really, really important in video games. If you're going to backstab somebody, are we looking the same way? If we're looking the same way, and my melee attack, which came out of me, I'm B, hits him, then it's a backstab. But if the dot product is 0, that means I'm hitting him from the side. It's not a backstab. And if the dot product is negative, I'm stabbing him to his front. It's not a backstab either. And so what if you come up and use a vending machine? If the vending machine and I are looking the same way, I just hit the back of the vending machine. So no, don't activate anything. Only activate the vending machine if I'm looking at it. And I'm looking at it when the dot product is negative. So this is one of the fundamental tools, one of the fundamental mathematical components that you have to know in order to make video games. If you want to do anything interesting, like backstabbing or only allowing vending machines to be activated from the front. You know, maybe you will allow it to be activated from the back. It just seems like bad game design to me. League of Legends backstab is so broken. Yeah, okay. So we're going to dot product the direction we're looking with the vector pointing at the player. And so a vector pointing at the player is something called a displacement vector. So we have to get the location of the player, which is this one here. Let's just pull that over here. Get actor location. So we're going to get the location of the player, and we are going to subtract that from our location. Vector minus vector. The player's location minus our location. Okay. And so this is the vector coming out of here is this one. So we took the player's location and subtracted the starting location from it. So that is that highlighted vector there. And we need to normalize it to make it unit length. Both of these have to be normalized. I think the forward vector is always normalized. Unit direction. Yeah, where it says unit direction there. That means it's already normalized. This thing is not going to be normalized. So we need to push that into a normalize node. And so this will give us a vector of length 1 pointing towards the player. So this is a vector looking straight ahead of us. And then the result of this here is a vector of unit length 1 centimeter pointed from us towards the player. And with these two vectors here, we can dot product them together. And what we will do is we will just print the values. Print string. And let's just make sure this works before we do anything else. Make sure it works. So we're just going to do that there, do that there, and take the return value and print it. No, that's duration. No, no, no. No, not the duration. So you... Okay. It's kind of like a little bit of spaghetti here. But this is a... this code here takes the dot product of the direction you're looking and the direction to the player. And we're going to just print the results, and we're going to get an intuition for like what numbers would be good for it seeing us and stuff. And then I'm going to cut off the rest of it because I actually don't want it moving. I just want it stationary. Then I'm just going to like kind of like walk around and see what kind of numbers are reasonable for me being in front of it. So compile, save, and play. Okay, so you can see the Goblin there is every second it's thinking, and right now it's printing out what the dot product is. So when I'm directly in front of it, it's going to give me a number near 1, because the direction it's looking and the direction towards me are very close to straight on. Okay. So 98, so that was almost exactly in front. Now if I walk behind it, you'll see these numbers turn negative. So when I'm behind it even a little bit, it'll already be negative, but the more behind it I am, you see how it gets very close to -1, right? So this would be like a perfect backstab, right? And you would have to kind of decide, like, okay, if I hit it from this angle or this angle, and this is honestly what I do when I make games. I just sit there and print the numbers, and I just kind of eyeball it. Like, okay, well, should it be able to see me here? Yeah, probably. What about here? Probably not. No. What about here? Yeah. What about here for a backstab? You know. What about here for a backstab? Here's negative 0.87. What about here? You know, negative. Okay. What about here? What about here? You know. And so I just sit there and I just print out the numbers and just see what kind of feels right to me. Like, what do you? I mean, what do you guys think? Do you think this should be a backstab? Like, if I stabbed it here with my sword, should it do double damage or whatever? What do you think? Yeah? Nah? Right now it's at negative 0.65, so maybe here, negative 0.76. What do you think now, Walker? You think this is backstab territory? Yeah, okay. So yeah, basically you just kind of play the game and you just kind of scooch around, kind of get a feel for the numbers. So, all right. So, do you think that the Goblin should be able to see me here? What do you think? Yes. Okay. So I'm within its line of sight. Okay. What if I come over here? I'm down to 0.6. So where I was before, you see what I'm doing? I'm just kind of looking at the numbers coming out. So here it's like at 0.85. Everyone's like, yeah, okay, 0.85's, yeah, pretty good. What about over here? Now I'm down to like 0.67. Do you think it should see me? No? I don't know. It's kind of like borderline to me. Maybe here? 0.8. What about here? Do you think it should be able to see me here? Over 0.75? Okay. Yeah, so right around here. Somewhere like that. Yeah, seems fine. Yeah, these are the kinds of things you just sort of play with them, you know. So what we're going to say is that if that dot product is greater than 0.75, if that dot product is greater than or equal to, it doesn't really matter which you pick. Put a branch in there. 0.75. So if the dot product is greater than 0.75, then we will go on and do the line trace. If not, then actually we will do the simple move to location. Right. So if it can't see us, it'll just randomly walk around. If we are within the cone, then it will do a line trace, and then if it can see us and we're within the cone, then it'll move towards us. Okay, so if we do that, then you can see here it's not doing the line trace at all. You see that? Because we're not in its cone. Sort of randomly. See, there you go. So now we're within its cone. It's going to start chasing us. It lost us. Interesting. I think the cone might be a little bit narrow. There we go. All right, it sees us. If we move just even a little bit off to the side, it's like, huh? Where do you go? Huh? What? Huh? What? Which way did this guy go? I don't even know. It's crazy. It might be a little bit too narrow. Okay. So that feels too narrow to me. So we will play with it and make it 0.5. Let's try that. See how that works out. All right. So now it's did you see how I did the trace line towards us? So at least we're within the cone, and it's tracking it. Oh no, it lost us again. Okay, there we go. There we go. There we go. All right. All right. All right. We probably should do a sphere trace maybe also, like if we're within... Ah, it stuck us. Ah, run away. Okay, so we got... I think we got, we got something pretty good here. Okay. So... we probably should have some radius search also, right? Because like if you're like right here, like it should hear you. You know what I mean? Like it should probably. I'm in full plate. Like I'm not stealthy. I should probably do like, what do you think? Like a meter or so. It's like I can't just like. Come at me, bro. Come at me, bro. Come on, come at me, bro. I can like right now. Oh, I can just run past it like that, and then it loses me, right? You just completely dodge past it like that. So maybe like what do you think, like a radius search or something? Yeah. Okay. Yeah. So because it behaves like this is one of those things. Like you just have to keep playing it and just be like, what kind of behavior do you want? Maybe if it's a dumb goblin, like maybe it's just like, oh look, a flower, and it just goes over and like. It just really depends what kind of behavior you want. I think probably because this isn't a stealth game. In a stealth game, people get annoyed if like they hear you when you are sneaking up and it's like, whoa, God damn it, But I think we should probably do a sphere as well. So okay, so if the player's within the cone, we'll do a line trace. I think we should just do the sphere trace always, right? It's like whether or not we can see the player. If the player is in the cone, do a line trace. So, yeah, we'll just like a little radius around us, and if we hear the player essentially, then we'll immediately just have it move to the player. Otherwise, we'll just go on to the rest of it. Okay, so let's make a little bit of room here, and you guys can go away. This is called dot product. To see if the player is in front of us. And dot product, like I said, it's just one of those really important tools. Are two vectors pointed the same way? That's the question it answers. Are two vectors pointed the same way? Are they at right angles to each other? Are they pointed in opposite directions? That's what dot product gives you. There's also something called cross product that we'll talk about, which is a 90 degree rotation of it. So is something to the left of me, is something to the right of me. We use cross product. Dot product is something in front of me or behind me, or orthogonal. So let's do a radius trace. Sphere. Trace. Right channel. So let's move this a little bit more out of the way. Oops. Okay, so we're going to do a sphere trace. We're just going to do a little bubble around us. So the starting location is going to be my eyeball. The ending location is going to be my eyeball. The radius is going to be, let's have it be 2 meters, like that. Trace channel, visibility, draw debug type. Let's draw it for like a second. Because, well, let's draw it for 2 seconds so you can see the last 2 things. Okay, so split that out. This is going to hit everything, isn't it? You need to do a multi. Sphere trace. So it's going to give us everybody. Or we can just, yeah, there's an even easier way of doing this. We don't even need to sphere trace it. We can actually just get the distance from the player to the goblin. And so we can do that by using another power of mathematics, which is called vector length. So vector length is also known as the Pythagorean theorem. So if you want to know how far apart this point is from this point is, you just do the Pythagorean theorem. And in Unreal Engine, it's called vector length. And it'll just tell you how far apart 2 points are. So if the goblin is within 2 meters of the player, then they're close enough to here. Okay, so we don't even have to do a sphere trace. It's overkill. So what we're going to do is we're going to do vector length. So we've got the location of the player. We got the location of the eyeball. And we are going, actually it's this one here. This is the distance from our eyeball to the player. Okay, so that is the, so that one we're just going to do vector length. And so that's going to tell us how far away the player is from the gobbo. Because that's the goblin's, that's the player's location, that's the goblin's location. You subtract them, that gives you this vector here. And so just the length of that vector is how far apart they are. Okay, so the power of mathematics allows you to just very quickly and easily do things like that, you know? When you get conversant, and you have the whole semester to get conversant in this, there's just, there's like 5 or 6 different mathematical tricks like that that you just need to know if you're going to do game development. And they're not too bad, I don't think. So this is how far apart the player is, and so we'll just compare this. If it is less than or equal to 2 meters, if the player is within 2 meters, and this will be piped into a branch. So if the player is within 2 meters of the goblin, I'll just make this comment bigger. If the player is within 2 meters of the goblin, attack. Doing the traces in C++ is annoying. Yeah, it is. I really like working with blueprints. It's just, I don't know, it's very easy. Okay, so if the player is within 2 meters of the goblin, then we will move to player. And if it is not within 2 meters, then we'll just do what we were doing before. So if the player is within 2 meters, we attack, we do the move to player. And if it's not, then we just do the same cone, line of sight, blah, 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 as before. And by doing this, I think we should end up with an AI that will, there we go, there we go, there we go. So we swing around here. Nope, no, we dodged it. Huh. Okay, that didn't work. It was before we normalized it. No. Print string. Let's print the length. here. So every time it thinks, it's going to tell us how far we are away from the player, and that'll tell us if we did something wrong. So 1,300 units away. Okay, 346. Okay, so basically the problem is I didn't make the radius big enough. Okay, so like it should be like, what is this, about 500 here, 260, 150, 300. Yeah, I'll just make the radius like a little bit bigger and see if that works. Make it, if we're within 5 meters, then it'll hear us. Yeah, see how I can't Torah it anymore? So if I'm within 5 meters of it, it just finds me, even if I'm behind it. So that looks about right. Might be a little bit. Nah, go away. And now I've lost it. Okay. Oh, now it found me. Okay. What do you guys think? I just need to clean this damn thing up now. All right. So this part. That's really part of the trace line. And what degree cone is this? Well, the number that we're talking about here, 0.5, that's actually the cosine of the angle. So if you're wondering what angle cone we have here, we can just open up calculator and does get time seconds return the same value that event tick delta seconds would return? No. Event delta seconds returns how long it's been since the last frame. Get time seconds is just the current clock in the world. It's 34 seconds has elapsed or something like that. But it does, it is affected by time dilation. So if you do bullet time or something that slows the world down, or if you pause, the game time seconds pauses also, which is usually what you want, unless it's not. Okay, so 0.5 inverse cosine, it's a 60-degree angle. So the Goblin has off center, 60 degrees to the right, 60 degrees to the left, a total field of view of 120 degrees. So the Goblin has a field of view of 120 degrees, and it can also detect any human within 5 meters of itself. So there you go. That's an AI. The dot product tells us if two vectors are pointed the same way. In this case, the direction to the player and the way we're looking. But they're useful in a lot of situations as well. And then this part here, why are you over here? No, I'm just going to clean this up a little bit. I really don't need... Let's make another one. Over here. On. There. I'll cut down on the amount of spaghetti that I got going on. Let's pull you out here. Oops. Okay. So this will be your homework assignment. Make an AI. Okay. We didn't quite get to this part here is think once per second. So each of these blocks is actually really good for you guys to know. So the ability to think once per second I've already posted onto Discord. Dot product to see if a player's in front of us is now going to be on Discord. If the player is within 2 meters of us, that is the vector length of So what we're getting is the length of the displacement vector here. That's how far away the player is from us. If the player is within a... Why is that so big? Get location of the eye point. You really don't need to be that far away, do you? Okay. There. Spaghetti under control. Mostly. Mostly under control. So there we go. The player's in the cone, do a line trace. So if they are within a 60-degree arc on either side of the direction we're looking, then we do a line trace. Otherwise, we just randomly move around. And finally, let's do this. Our final thing is we are either going to randomly move around or we are going to move to the player. And the move to player function looks like this. As always, if you need help on the assignment, the last think it defaults to 0, but that doesn't matter too much. I guess it does. And then think delayed defaults to 1. So that means once per second. If we want to think more often, we can decrease that value to 0.1. Then it would think 10 times per second. If we set it to 5, it would think once per 5 seconds. So you can control how good your AI is. This is like your AI update rate. Right now it's 1 hertz. Yeah, as always, if you have questions about the homework, please ask on the Help Center. Don't just like potato on it, you know what I mean? Just like give it a shot. And this is a good. Today was a good day. I think this was a pretty good hour and a half spent learning how to make an AI that can walk around in the world. Haven't quite gotten to damage yet. Haven't gone to heads-up displays yet, but we still got quite a few weeks left in this semester. So, yeah, Nav Mesh is really important. Dot products incredibly important. Line trace is incredibly important. These are like your basic like tools that you use to do stuff in a world. And vector length is very important. How far away are 2 points? Like you do that all the time. You know, you shoot somebody. How far away is it? If you want to do bullet fall off, right? Where like the further away somebody is, the less damage the bullet does. You take your location, their location, subtract it. That gives you that displacement vector. Take the length of it. Okay, they're 500 units away. They're 1,000 units away. They're 2,000 units away. And then you use the length of the difference of the locations to determine how much damage you do. Like these are your like tools. Like you got to know your tools, and then you can just put them together to make whatever you want in a video game. And after a while, once you know all the tools, then it becomes a matter of creativity. And you just get to like, whatever my mind can dream up, I can make a video game for it. And that's kind of a cool place to be. Plus you can get a job, maybe. Who knows? So that's it for today. And we're going to switch over to the IS-50B people in just 1 second. Just give me a couple minutes to break. And then we'll pick up with IS-50B in a second. All right. Thanks, you guys. Do this. That's your homework. All right. See you next time.